Hello, welcome to this tutorial on categorical features processing using label encoding and one-hot encoding. Categorical features are non-numerical data such as gender, color, or any other characteristic that cannot be quantified in numerical terms. Machine learning algorithms often require numerical data, so categorical features must be converted to numerical format to be used in these algorithms. In this tutorial, we will discuss two common techniques for converting categorical features, label encoding and one-hot encoding. By the end of this tutorial, you will have good understanding of these techniques and be able to use them in your own data processing tasks. Label encoding is a technique for converting categorical features into numerical labels. Each unique value in categorical feature is assigned a numerical label. For example, if we have a gender column with values male and female, we can assign labels 0 and 1 to these values respectively. The labels are typically assigned in alphabetical or chronological order. Label encoding can be useful for ordering data, where there is a nature ordering to the categories. For example, an educational level column with values high school, college, and graduate can be assigned labels 0, 1, and 2 respectively. Here's an example how we can convert the target column, which has the values yes and no, to label encoding using Python. So the first line of the code imports the label encoder class from the Scikit-learn preprocessing module. The label encoder is a class in the Scikit-learn library that's used for label encoding of categorical data. The next line of code creates an instance of the label encoder class and assign it to the variable li. This instance of the class will be used to encode categorical data. The third line of code applies the label encoding to the target column of a pandas data frame df. The fit transform method of the label encoder class is called on the target column to encode the categorical data into numerical labels. The code labels are then assigned back to the target column of the data frame. Finally, the head method is called on the data frame to display the first few rows in the encoded data frame. This allows us to see the transformed data and verify the label encoding has been applied correctly. And if you look to the new data frame, encoded data frame, so the target values now has the value 1 and 0 instead of the previous data frame, which was the values which were yes and no. So the question now, if we need to use label encoding for more than one column? So in this example, we will use label encoding for two columns, 6 and target. The first line of code imports the label encoder class from the Scikit-learn preprocessing module. The label encoding is a class in the Scikit-learn library that's used for label encoding of categorical data. The second line of code defines a list of columns that contains the names of the column that we want to apply label encoding to. If we go to the third line of the code, applies the apply method to the subset of the data frame that contains the column specified in calls. The apply method applies function to a data frame or a subset of data frame. In this case, the function being applied in label encoder.fit transform, which creates an instance of label encoder and fit it to the data in the specified columns, then transform that data into encoded labels. The fourth line of code assign the encoded data back to the original columns in the data frame. Finally, we use the head method in order to display the first few rows in the encoded data frame. This allows us to see the transform data and verify that the label encoding has been applied correctly. However, it's important to note that label encoding can create unintended relationships between categories. For example, in a day column example, machine learning algorithm may interpret a label of 1 as indicator a higher value than label of 0. Or for example, a label of 7 indicate a higher value than label of 3, which is not necessarily be true. One other technique for processing categorical features is one-hot encoding. One-hot encoding is a technique for converting categorical features into binary columns. A binary column is created for each unique value in the categorical feature. For example, if we have a color column with a value red, green, and blue, we can create 3 binary columns with values 1, 0, 0, 0, 1, 0, and 0, 0, 1, respectively. Each binary column indicates whether the original column had that value 1 or not. Of course, one-hot encoding is useful when there is no nature ordering to the categories. It also prevents unintended relationships between categories that may occur with label encoding. However, one-hot encoding can create a large number of features, which can be computationally expensive for large datasets. It's important to keep this in mind when choosing between label encoding and one-hot encoding for particular data processing tasks. In this tutorial, we discussed 2 common techniques for processing categorical features, label encoding and one-hot encoding. Label encoding is useful for ordinal data and assign each unique value in a categorical feature a numerical label. However, label encoding can create unintended relationships between categories. One-hot encoding is useful when there is no nature ordering to the categories and create binary columns for each unique value in the categorical feature. However, one-hot encoding can create a large number of features and can be computationally expensive. When choosing between label encoding and one-hot encoding for a particular data processing task, consider the nature of the categorical feature and the computational resources available. Thank you for watching this video. We hope you found it informative and useful for your data processing tasks.